When a statement and its converse are both true, you can write them as a single biconditional statement. Any valid definition can be written as a biconditional statement. Now, what does it mean to be a valid definition? Well, it's very much like what a biconditional is. A valid definition is when the statement and its converse are both true. So, is the following statement a definition? We'll go back to that statement that we've been using over and over again, that if it is raining, then there are clouds in the sky. Well, think about it. Is that a valid definition? So, the original conditional is true. We talked about that already. But now if we think about its converse, which we wrote in the notes earlier, that if there are clouds in the sky, then it is raining. That's false, right? You could have clouds in the sky without it be raining. Therefore, this would not be considered a valid definition. We can't write it as a biconditional. Now let's say we have this statement. If an angle is a right angle, then its measure is 90 degrees. So, can we write it as a biconditional? Is it considered a valid definition? So if we look at the original statement as is, if an angle is a right angle, then its measure is 90 degrees. Is that true? Yes, it is. Okay, so let's consider its converse. The converse would be, if its measure is 90 degrees, then it's a right angle. Is that true? If an angle has a 90-degree measure, is it a right angle? Yes, it is. Therefore, it is, the converse is true and the original is true. So we can write it as a biconditional. So let's see what that looks like. A biconditional has a very special phrase in it, which is if and only if. So if I wanted to write this statement, if an angle is a right angle, then it measures 90 degrees, as a biconditional, we use this phrase right here, if and only if. So, an angle is a right angle if and only if its measure is 90 degrees. Alright, so let's look at another example of writing biconditionals. If we have the statement, if two angles are vertical, then they are congruent. In order to determine if this is a valid definition, or if we could write it as a biconditional, you have to ask yourself, is the statement true? Well, is the original conditional true? If two angles are vertical, then they are congruent. Yes, and we've actually talked about that before. We will be proving the vertical angle congruence theorem in Chapter 2, but we know that if two angles are vertical, then they are congruent. Now think about the converse. The converse would be, if two angles are congruent, then they are vertical. So is it possible to have two angles that are congruent and them not be vertical? Yes, of course we can. So therefore the converse is false, and you cannot write this as a biconditional. It is not a valid definition. Let's look at another example. If two segments are congruent, then they have equal lengths. So ask yourself, is this a valid definition? Can I write it as a biconditional? So, is the original statement true? If two segments are congruent, then they have equal lengths. Yes, it is. We know that already. Now, look at the converse. If two segments have equal lengths, then they are congruent. Is that true? Yes, it is. Therefore, we could write this as a biconditional. The biconditional has that phrase, if and only if. So, if I get my highlighter, here's my special phrase, if and only if. Two segments are congruent if and only if they have equal lengths.